Okay, hi guys. This is about fractional indices. I hope you remember what a fraction is, right? A fraction, like 1/2 is a fraction, 3/5, and these are fractions, right? And let's look at indices. Okay, now you have been told, and it is true, that if you have like a cubed, that would be a times a times a. And it's true, but it also is sort of a trick, because this is not really what it means. You see, there is going to be a problem if you have, for instance, a to the power 3.5. What happens? What is it? Is it a times a times a? So we've got 3 of them. Now I need a half more. What is that last bit? You see? A bit of a problem. So we need to define now how to work with these fractional indices. So let's have a look at this. We do know that a to the power 1/2 multiplied by a to the power 1/2. Now that's, you add up the indices, remember? Remember that you had like, 2 to the power 3 multiplied by 2 to the power 4, then that would be 2 to the power 7. You've learned that before. So this a to the power 1/2 multiplied by a to the power 1/2. We add the indices. So that's a. Now I also know from previous experience that the root of a multiplied by the root of a, so the root of any number multiplied by the root of the same number, that is a as well. Now if that's true, then obviously a to the power 1/2 must be the same as the root of a. A to the power 1/2 must be the same as the root of a. Can't be any otherwise. 2 equal things multiplied are a. 2 equal things multiplied are a. Therefore these must be equal. So the result here is that a to the power 1/2 actually means the root of a. So that's how we work with fractional indices. And now they know that here a to the power 3.5 is a times a times a times, what needs to go there is the root of a. Right? Now if we extend this knowledge, the root of something is called the square root, right? The square root. So that square thing that indicates that there's a power 2 involved, square root. Alternatively, you can have a cube root, or a quartic root, or a quintic root. Now, that all comes in place here, because let's have a different number, for instance b, doesn't really matter. So we know that b to the power 1/2 is the root of b. Now that actually is the square root of b, so it's the second root of b to the power 1. So that 1 goes there, the 2 goes there. With that convention, with that definition, b to the power 3/4 just means that it is the fourth root of b to the power 3. So b gets cubed, and then we take the fourth root of it. We take the root twice. B to the power 2/5 means the fifth root of b/2. Now the thing about these is that these are not really handy to work with. So most of the time you will convert roots to indices that way. Because when you convert these roots to indices, they get easy to work with. For instance, b to the power 1/2 multiplied by b to the power 3/4, you get to add up the indices. So that's b to the power 5/4. That's much easier to do than to multiply the root of b multiplied by the 4th root of b cubed. You couldn't do that unless you first convert to indices, and then you find the answer easily.